Explain the concept of exactly once semantics, EOS, in Kafka.
So in Kafka, we have three different semantics are available. One is like exactly once semantics, and at most once a semantic, and at least once semantics. So exactly once a semantic can specify that there is no duplication of the data and there is no loss of the data. So each message can read once and process once and write once. So it will go in a only one record fashion. So that tells about this exactly one semantic. But we have other things like at least one semantic, like it will send the data at least one time, and at most one time, at least one time can have more duplicates are also possible in that, like to processing the duplicate kind of records. So at most one it will send at most one record that it will send in case the data loss might be there. So the key features of like exactly once a semantic is like atomic operation. Like it tells the semantic can tells that we need to read the message from the Kafka once and process it once and write to once. So this will complete all read, process, write is treated as a single atomic operation. If any part of this sequence failed, none of the changes were applied. So this means that either all operations are succeeded or none. So preventing partial updates that could lead to a data inconsistency. Like if you have a requirement where the data should be consistent all the time, then we can use this exactly once semantics. So the other benefit is like it can support the idempotent producers. Like Kafka producers should support the idempotent producers, which means if the producer sends the same message multiple times, like duplicate times, it will only be written to Kafka log at once. So this feature eliminates the duplicate messages caused by the network issues or produced failures during the message transmissions. And the transactional support, Kafka introduced transactional support in version 0.11 onwards, and it ensures that producers to send messages to multiple partitions and topics atomically. Like if any transaction is committed, all those messages will be visible to the consumer. If the transaction get failed, none of the records or messages will be visible to the will not visible to the consumers. So this how it can support the transactional support. And the consumer offset management, like Kafka manages consumer offset in a way that ensures that they are only committed after the processing is complete. So this prevents a scenario like where consumer might read a message but fail to process before committing its offset. So this could lead to data loss or the data duplications. So these are all the features that exactly one semantic has. So to support this exactly one semantic, we need to do it in a Kafka. Like Kafka producers should follow this, should enable this idempotence true parameter or a configuration that enables that duplicates do not send the result in a duplicate record, and should use the transactions like application APIs, transaction APIs to group the multiple send records into a single transaction, and should available the read committed isolation in the consumer offset. So by implementing these methods, we can enable this exactly once semantics in the Kafka.
How would you monitor and optimize Kafka performance in a production environment?
So monitoring and optimizing Apache Kafka performance in the production environment is important for data reliability and efficiency for the streaming application. So coming to the monitoring Kafka performance, like we need to monitor the metrics, like the throughput, the latency, and the consumer lag, and broker resource utilization, and under replicated partition. So these are all the metrics that we need to keep an eye in the Kafka cluster. So throughput measures that the number of messages produced and consumed per second. So and the latency is like track the time taken for messages to be produced and consumed. So high latency can also indicate some sort of a bottlenecks in the processing. And the consumer lag, like what is the time it has taken for last record that it has produced, and what is the time it has taken to process the last consumer record. So the high lag between the producers and the consumers can also lead to the performance impact. And broker resource utilization, we need to keep an eye on the CPU, memory, disk IO, network IO uses between the brokers to identify any issues, and the hard disk size also we need to maintain. And also we should see the metrics like under replicated partitions, like we need to monitor the partitions which are not have enough number of replicated instances, which can lead the data loss. Like usually the monitoring tools that we can use, like we can use the cluster manager for Apache Kafka. So this is a tool offers a user friendly tool with a UI, can monitor for cluster health, and it includes the broker status and partition distribution and consumer group details and all. And we can also use the Datadog. This observability platform integrates with the Kafka that provide the monitoring capabilities, include real-time and alerting based on the performance metrics. And also we can use the Prometheus with Kafka exporter. Like Kafka exporter can collect all the logs from the Kafka cluster, and we can send it to the Prometheus. So Prometheus, using the Prometheus, we can visualize it, and we can query the metrics, different metrics, and we can use the Grafana to visualize the dashboard for these metrics. So these are all the different monitoring tools that are available for the Kafka to monitor its status. And best practices for, like, we need to enable the alerts for this metrics, so that based on some threshold, like if any CPU or input output or memory threshold reaches to maximum 80% or 85%, it should send an alert message or alerts to the users saying that it is getting increased, so that the users can take a look of it and can diagnose that details and can fix an issue if there is any. So these are all the techniques are partition these are all the techniques that are available in Kafka to monitoring the tools. So to optimize the Kafka performance, like we need to do the configuration tuning, like we need to adjusting the number of the partitions, like increasing the number of partitions for high throughput topics to allow more consumers to read in parallel. However, balance with this overhead of managing is too many partitions. So balance maintaining of too many partitions are like overhead will be increased. And the producer configuration, like we need to optimize the producer settings, something like acknowledgement and the batch size, like how many records that we are sending to the Kafka, and also the linker messages to enhance the throughput, and while managing the latency. On the consumer configuration side, we can tune the configuration settings, something like fetch minimum bytes and max poll records, to optimize how many records that we need to consume from the consumer. On the resource allocation, so we need to ensure that all the brokers has enough CPU, memory, and disk and all other resources to manage all these workloads. And we need to regularly monitor the status of all these broker systems with this all the metrics, and we should enable the metrics. So based on the metrics, we have to free up the space, and we have to do some sort of a cleaning activities, and ensure that each broker has enough resources are free to handle the load. And also we need to work on the data retention policies, like we need to keep the data retention policies as per our business requirement and the processing requirement. Keep less data retention policies, so that the system need not to maintain the huge amount of the data all the time. So we should have a proper purging mechanism should be in place. And we should do the regular maintenance. So perform the regular maintenance tasks, such as cleaning up the old logs and optimizing the topic configurations, and reviewing broker health to maintain the optimal performance. So by following all these practices, we can optimize the Kafka cluster performance.
How would you design a Kafka based system to guarantee data consistency in the event of node failures?
Designing a Kafka-based system to guarantee data consistency in case of any node failure, we need to implement the multiple strategies and multiple practices that we need to follow. The first thing is utilize the Kafka replication features. Like we have to give the enough number of replications while creating the partitions. So defaultly, typically as a thumb rule, we should give the 3 or more. Like this ensures that there are multiple copies of the data across the Kafka brokers are available to handle any of the system failures. So in case any one of the Kafka broker node get failed, so the data still be available with another nodes, so that the data can be we can resume the operation from where it can left off. And mostly we can choose the in-sync replicates for the leaders approach. Like whenever any leader node gets down or crashed, it's like, right, so we should choose the in-sync replication so that it will be most sync with the leader approach, so that it will be more eligible to process the messages without any delay or without any data loss. And we should implement the idempotent producers. Like we can use this configuration, like set enable idempotent equal to true. So this will actually prevent the duplicate records being written to the Kafka, and it will help to maintain the consistency across all the downstream systems. And we should use the transactions for atomicity. Like as I said in previous query, like we should previous question, like we should use the transactions for atomicity, like transactional producers and consumer offset management. So like transactional producers, producer should use that transactional API, so that either all the messages are getting committed to the Kafka, or none of the messages are getting stored to the Kafka. So that ensures this transactional producers. And so in the consumer side, so once the consumer reads from the Kafka and process and store it into downstream system, then only we should mark the message as like committer offset, so that the next run or next micro batch run, it will take the new offset and it will process from there on. And we should design for fault tolerance. Like if there is any failure in the system, we can able to handle that. In the consumer group, we should make the more consumer, so that if any one of the consumer fails during the processing, other consumer could take from there it left off and will start reading from there on. So this is how we can maintain this fault tolerance in the consumer groups. And also error handling mechanism, like implement a robust error handling strategies, something like a retry mechanism for transient failure and any other issues. And we need to maintain the idempotency across the components. Like idempotency we can implement only in not only in the producer, but we should also implement even in our downstream systems, and also while processing the records in the Spark streaming. Like in the downstream system, we should use kind of a upset model, so that even the record appears as a duplicate, it should be updated as like updated, it's not like a new insert. So this is how we can handle this idempotency in all the components. And we have to monitor the system performance, and we have to monitor and we have to maintain the system a period. So we can fix all those things. So this is how we can design a system to handle the fault tolerance.
How do you run the Spark batch job to read from Kafka?
So to run the Spark batch job to read from the Kafka, it can allow by using the Spark SQL APIs. So first we need to set up the dependency, Spark SQL Kafka dependency, and we need to create the Spark session, and we can read the data from the Kafka using the read method. To consume the message from the Kafka, we need to specify the format as like Kafka, and we should define the Kafka bootstrap servers, and we should subscribe to a topic. And to read the message, like we can use like a Kafka select expression, like we can read it as like a key and value format, and we can parse it, and we can write the data to some other destination, something like a S3 or HDFS. We can use the write method, like data frame dot write dot format as the whatever the format file format that you wanted to define for, and we can store it into the persistent storage. Or if you wanted to store back data to the Kafka again. So we can use the format as like Kafka, and we can define the bootstraps and the topic, and we can use the save method. So by running this code, we can read the data from the Kafka using the batch mode, and we can write the data to the Kafka or any other external systems.